Okay, so to give you an idea of what our goal is, before we start delving into some of the operations of matrices, I want you to get the big picture here. So first off, we start with a system of equations. So we have a system of equations with 3 variables, 3 equations. I'm going to then, step 2, make an augmented matrix out of that system of equations. We've already practiced that. If I can get this matrix to look like an equivalent matrix, but in row echelon form. Remember, row echelon form is where you have ones down the diagonal, we have zeros beneath them. If I can make the original augmented matrix to look like a matrix in row echelon form using row operations, then I can rewrite it in equation form. Then I can use back substitution to solve the equation. So this is the plan. Step 1, start out as an equation. Step 2, augment a matrix. Step 3, which is the big question, how am I going to get my matrix to look like an augmented matrix? Again, we're going to get there. That's the part we're going to cover next. Once I have it in row echelon form, I can rewrite it as a system of equations, then back substitute to solve. That's the big picture of where we're going with this. We need to focus in on this step right here. How in the world are we going to get a augmented matrix to look more like an reduced row echelon matrix? So what we need to do there is we need to learn about row operations first. There are 3 types of row operations that produce matrices that represent systems with the same solution set. So I'm going to be changing my matrix in each step to give me a different matrix, but also gives me the same solution set. Okay, so one row operation that I'm allowed to do that is going to produce a different matrix with the same solution set is interchange 2 rows. For example, if I have the first, second, and third row, and I prefer the first and third to interchange, this is how we write that: instructions, row 1 interchange with row 3. If I do that operation, notice I'm messing with row 1 and row 3. Row 2 stays the same. So the first thing I like to do is write whatever stays the same. Row 1 will end up in row 3. Row 3 will end up in row 1. Okay, so why did I tell you to do that? Well, in this case, I wanted this first number 3 to be a 1. By changing the 2 rows, I was easily able to get a 1 where I wanted it. Okay? The next operation that we're allowed to do is to multiply a row by any non-zero number. So if I want to take a row like row 3 and multiply it by 2 and put it back into row 3, I'm allowed to. So this is the set of instructions that I was asked to do. Take row 3, multiply it by 2, put it back into row 3. So who am I changing? I'm only changing row 3. So the first thing I need to do is rewrite the rows that aren't not changing at all. Row 1 and row 2 aren't changing at all. All I'm doing here is I'm taking the entire row 3 and multiplying it by 2. So when I multiply 3 times 2, it gets me 6. 2 times 1 gets me 2. 2 times negative 1 gets me negative 2. 2 times 9 gets me 18. Okay, so that is another operation you are allowed to do. Sometimes it's going to help us, so we're going to learn how it helps us in the future. The next thing that we're going to do is multiply a row by a non-zero number and then add it back to that row or any other row. So I have 2 examples here for you. The first example says I want to take row 1 plus row 2, and then this arrow says put that answer back into row 2. Then my second part, I'm going to take negative 1 times row 1, add it back to row 3, and put it back into row 3. So I'm going to give you 2 examples here. First of all, notice that I'm messing with row 2 and I'm messing with row 3. So who stays the same? Row 1 stays the same. So the first thing I like to do is rewrite whatever row that you're not changing. Alright, So when I'm trying to find row 1 plus row 2 and put it back into row 2, I will do that in red. One way to do that is to write it horizontally. So when I have row 1, I have 1, 2, -1, and 0, and I'm adding it to row 2. Well, who's row 2? -1, -1, 3, and 3. Notice that I wrote my row 1 down vertically. I wrote my row 2 down vertically, and now I'm going to add them horizontally. So I have -1 plus 1 gets me 0. 2 plus -1 gets me 1. -1 plus 3 gets me 2. 0 plus 3 gets me 3. So into row 2, I can rewrite 0, 1, 2, and 3. So that's one way to show your work by multiplying a row by a non-zero number and then adding it to any other row. I'm going to show you one other way that you could have done this. Another way of doing it is, I would think, more vertically. So if I want to take row 1 plus row 2 off to the side of your paper, this one, out of all three of the operations, this is the one that causes a little bit more extra work. So you're going to have to find some paper to do your work off to the side here. So this is another way of doing the exact same work. If you just put row 1 horizontally, row 2 horizontally, and then add down, you're still going to get 0, 1, 2, and 3. I don't really care which way you do it. You still need to get 0, 1, 2, and 3. Now let's do the other work in purple here. So I have -6 times row 1 plus row 3. I need to do that 4 times because there's 4 columns. So to do it vertically, I would say -6 times row 1. My row 1 is 1, 2, -1, and 0. And then I'm adding it to row 3. So I look at my previous matrix, and that's 6, 2, -2, and 18. And then I'm just going to multiply and add across. -6 times 1 is -6 plus 6 is 0. -6 times 2 is 12 plus 2 is -10. 6 times 1, -6 times -1 is +6 minus 2 is 4. -6 times 0 is 0 plus 18 is 18. So my answer across the bottom would be 0, -10, 4, and 18. I'm plugging that into row 3 because that's what my instructions told me to do. And that's a perfectly fine way of doing it. Another set of work to do it a different way would be this way. Either way, you're going to have to show your work off to the side somewhere. If I take -6 times row 1, I'm just going to go ahead and take my row 1 from my matrix and multiply it by -6. So 1 times -6 is -6, 2 times -6 is -12, -1 times -6 is +6, and 0 times -6 is 0. Then I write row 3 below it, and then I can add down. It's the same exact answer. Do I care which way you do it? Not really. I just wanted to show you both ways so that you can pick whichever one you like the best. So why was that helpful, this last step? Notice I had a 1 here, and I was able to get a 0 and a 0 below it. Did you notice that now my original problem is getting to be a whole lot more similar to what my reduced row echelon matrix would prefer to be? I like the 1s down the diagonal, I like the 0s, and that's what I'm trying to do here. So these 3 row operations are going to help us to get augmented matrix into a row echelon matrix with the 1s down the diagonal and the 0s below it. So to be very clear, you need to do the steps in this order. Do not try to be creative. Do not try to save 1s and 0s so that you can get them later. You have to do this in this row. The first step is to get a 1 up in the upper left-hand corner. That's the first step. There's a couple different ways to get that, and we'll talk to you about how to get a 1 or how to get a 0 in a minute. Next, you want to keep that 1 there while getting 2 zeros below it. In order to keep the 1 there, you need to follow my instructions about how to get a 0. Don't try to be creative at all. Once you have the 1 and the 0, 0, step 3 says keep the 1 and the 0 there, and also get a 1 on the second column, second row. Oh, this should be get a 1 in the second row, second column. All right, on the step 3, you have the 1, the 0 and 0, you have the 1. The next step is to get a 0 below it. On the last step, you're going to have the 1, the 0, 0, the 1, and the 0 from the previous steps. The last step here would be get a 1 in the third column in the third row. So this is the 5 steps to get a matrix into row echelon form. Okay, so in order to get your 1s and your 0s, you need to know how to get 1s and 0s, which is one of the most important parts here. How to get a 1. There's 2 ways of doing this. The first one is just to switch a row that may already have a 1, a convenient 1 in the correct position. This is almost always used, if possible, in the first step only. For example, if I am looking to get a 1 right here, and I happen to see that there's a 1, a convenient 1 that's in a different row, all I would have to do is take row 1 and interchange it with row 3 in this case, because it's the row that has the 1 in it, the convenient one. Notice that row 2 stays the same, so the first thing I do is rewrite that, and then I just switch the 2 rows. I'm allowed to do this because if my original problem with the equations was written in a different order, it would still be the same solution. Just because the equations were written in a different order, it doesn't really mean much, which is why I'm allowed to switch rows when I want to. Have I successfully got the 1 where I want it? Yes, I have. Yay. So that's one method of getting a 1, usually only used in the first step. The next method of getting a 1 is to multiply the row by its reciprocal. So on the second problem, I already have a 1 and I have a 0 and a 0. Yay. So what I'm trying to do is get a 1 where there's a 2. And I don't want a 2 there. I want it to be a 1. So in order to get this to be a 1, I could take the reciprocal of 2, which is a half, 1 over 2, multiply it by the row, and put it back into the row. That will successfully get me a 1 instead of a 2 in the second row in the second column. So who stays the same? Well, the first row and the last row aren't actually being touched in this instructions at all. This is my instructions that I wrote in order to get a 1 where I want a 1. So what is being changed? Well, the second row. So I'm going to take 0 times a half, which is 0, 2 times a half, which is 1, 4 times a half, which is 2, and 6 times a half, which is 3. Now, a lot of students don't like thinking of things as times by a half. If instead of multiply by a half, if you want to think about it as divide by 2, you're totally welcome to do that. Let's do this again using a different wording, but the same operation. If you take 0, divide by 2, you still get 0. 2 divide by 2, you get 1. 4 divide by 2, you get 2. And 6 divide by 2, you get 3. So multiply by a half is the same thing as divide by 2. If you want to think of it as divide by 2, you're welcome to. That is how you can get a 1. The next operation we need to learn about is how to get a 0. This is a very important step. In order to get the zeros below the 1s, first of all, you have to have a 1 already there. Notice I already have a 1 in the upper left-hand corner. What am I interested in getting now? Well, I'm interested in getting zeros below it. So I need to write instructions to myself in order to get the negative 2 to be a 0 and to get the 3 to be a 0. So let's work with the negative 2 first. In order to get this negative 2 to be a 0, the instructions say to get a 0, you need to multiply the opposite number by the row with a 1 in it and add it back to the row. Okay, let's take that real slow. Multiply the opposite number. So I have a negative 2. What is the opposite number of negative 2? Well, the opposite of negative 2 is positive 2. Multiply that by the row with the 1 in it. Which row has the 1 in it? Well, in this case, it's row 1. Row 1 is the row with the 1 in it. Then add it back to the row you're changing. In this case, I'm messing with the negative 2, so I'm putting it into row 2. Put it back into the same row. Let's do that one more time with the third row. If I want to get this 3 to be a 0, the instructions say multiply the opposite number. What's the opposite number of positive 3? Negative 3. Multiply it by the row with the 1 in it. Which is the row with the 1 in it? That's row 1. And add it back to the row that you're manipulating, and that's row 3. My answer will end up in row 3. Okay, so let's change this matrix to an equivalent matrix with the same solution. Who stays the same? 1, 2, negative 1, and 0. Row 1 stays the same. Row 2 and row 3 are both being changed. I told you 2 different ways you could write this. Let's do the first one in red here. 2 times row 1 plus row 2. If you want to do this, what I would think of horizontally, so we can add across. I have 2 times row 1. My row 1 is 1, 2, negative 1, and 0. My row 2 is negative 2, negative 2, 6, and 6. So when I add across, I'm getting 0, 4 minus 2 is 2, negative 2 plus 6 is 4, 0 plus 6 is 6. So when I add it, I get 0, 2, 4, and 6 for my second row. For the third row, I will show you the other method of using this, the other way of showing your work. Negative 3 times row 1 plus row 3. I don't really care which way you do it, just do it one of the 2 ways. Once you find one you like, stick to it the whole time. So if I take negative 3 times row 1, that gets me negative 3, negative 6, positive 3, and 0. Add it down to row 3, which is 3, 1, negative 1, and 9. So that gets me 6, negative 5, 2, and 9. So negative 3 plus 3 is 0, so it's 0, negative 5, 2, and 9. Okay, did I get what I wanted? I kept my 1, I didn't mess with my 1 at all, and I also got the 2 zeros that I was hoping for. So I am pretty happy that I was able to get what I wanted. I got the zeros, and I also didn't mess with my 1.